You could still lose this week.
I think I'm going to.
I need you to win.
Alright.
There's no way I'm checking.
Okay, I know we gotta get you one. Anyone else need a practice guide?
I think I'm done this week. Like, I don't think I can.
Well, you're gonna lose next year for sure.
It depends if Saquon has a good game or not. But what I've got going for me is if Saquon racks up the yards, maybe they don't get in the end zone, and the kicker for the Giants kicks some field goals. Because I picked him up since my kicker was on
I
bye.
didn't pick up that Ingram too.
Yeah, because Gronk was inactive. I was like, crap.
Anyone else need a practice guide?
Oh, but 135 points.
Anyone else not get one?
Jeez.
Okay. Alright, let's go through a couple of things here to make sure that we're good to go.
I was gonna play Watson, but he's on bye because I knew Mahomes. I knew
Hey,
the Cardinals
gentlemen,
passed
can we
defense
close
was
the door
good.
after?
Mr. Ward, it smells. That was Mahomes' worst game of the
I
season.
got lavender going right now.
It's not
Better.
loud. The Tyreek Hill.
Last class.
Yeah, he had 28.
High smell class?
Yeah, I turned on the air pressure.
He got in the crowd, he was like cheering, and then the next time he gets in the crowd, he danced the camera.
Alright. So, okay, hey, Monday, or sorry, Friday.
Sunday.
Thursday.
Okay, Friday, we talked about on these problems, you have to use the power rule. No matter what the problem is, I will require the power rule
How
for
will
it.
you know if we have a power rule?
Because I want to see the steps as you go. So like on this, like on this one, I want to see that you change this to the half power.
That's what we just, that's the trick of our game. It's where you can try to
What?
Just wait.
Wait, can I?
No, you start about homework.
Is it number
Okay.
Can I
Okay.
have one? Can I have one?
Okay, all right, so you have to change that to power rule. If there's a fraction, let's say something like this. All right, let's go like, let's go 14x on the top, and let's say this is x to the third. What you need to do first, move this up and make it a negative power. We talked about this last time, it was on Friday. And once this is on the top, then you can do it by the normal power rule, okay? Because these two will eventually add together to make x to the -2,
You're gonna do that?
and then you can do the power
Wait,
rule.
what?
Okay?
You're gonna do
Why
that?
are they adding?
You have to
the
use, you
multiply?
have to show me that you know how to use the power rule on whatever problem I provide you. I will not give you something like
No, you're
overly
gonna have an x on
difficult.
the top and then x on the bottom too.
Yeah,
Number
it'll be
two
something
is
like that.
pretty
It'll be
tough.
something where when you simplify, you
Couldn't
can
we just
immediately go to power
couldn't we
rule. I'm not
cancel
gonna,
out in the first part and
you can
then?
do that way. As long as you're changing it to where it's power rule, not chain rule, not quotient rule, that's what I care about, okay?
How think you can use that?
And then you can do the first derivative over that. Power, subtract
I
one.
don't know why it's.
Do we actually have to write out the power being subtracted?
Yeah.
I don't know why it's 2.5.
Okay.
Oh, because.
All right, number two, or sorry,
I have no idea.
3 and 4 we talked about on Friday. These are the product rules. Just be careful. I can throw anything I want in here. Especially like, for instance, I threw an e to the x. I could throw like a number to the power, like 5 to the x.
That's like
That's the
I
example.
want to make sure that you're kind of aware of what I'm going to have. I do want to see that you're doing it by the product rule. So I want to see that you know the basic setup to it.
Is the derivative of e to the x just
E to the x, yeah. All right. Now, we finished with 5 and 6. I believe I did number 5 on Friday, so if you want to go back and watch videos, I post them on Saturday morning, so you can kind of watch those. Tonight's videos I'll try to post about 6, 7 o'clock, because that's when I'll be done with basketball for sure. I just want to make sure that you're trying to do that with the power, or with the quotient rule. Okay, let's go to the last page here.
Wait,
Okay.
which one's the quotient rule?
The one that's like.
Derivative first,
Say
minus.
quotient rule. There you go. 9 and 6.
I was just.
Okay, all right. 7, we have to do chain rule. Okay, these problems. Okay, these problems require that you show me the understanding of what you know chain rule is. That's kind of what I'm looking for. I want to see the main part now. This one looks like it's just the quotient rule, but this right here, just this little piece requires chain rule.
Oh.
E to the 3x, because the derivative of e to the x is e to the x, right? It's e to the 3x. But then you have to take it times the derivative, which is 3.
Okay, quick question, is that e to the 3x plus 7x or e to the 3x and then plus 7?
This is the power, and then they're adding a 7x in the back.
Oh,
So it's more like this,
So
Did you do this the same as I did?
like that. That's what it looks like.
Did you do like 3x
On test
plus
day,
7
I'll put them on the
3x
board and
in
we'll
the
make sure
power?
we walk through them. Question?
Yeah, on number 7,
when you do when you drop the power out front and make that, you have to put the derivative. Is that
Make a-
added on the back or
That's multiplied, always multiplied to the back. Is there a certain one up here you want me to go through, like 7 or 8?
Eight.
Good choice. It's definitely the harder one. Alright, so let's go through this one. The only real chain rule is just this thing. That's really the only part of the chain rule we're gonna have to do. So it should be somewhat easy. I saw a couple people trying this on Friday that were here. They're just getting they're getting like stuck right there in just that little piece. So it's overall it is the quotient rule.
Oh, it's not gonna subtract anything.
It's the quotient rule, but you can change this problem so that you can show it's a chain rule. I'll show you 2 different ways of doing this problem in case you like it, in case you don't. Okay, so if you're gonna do it by the quotient rule, and then we'll do chain rule later, this is how you do it. Derivative of the top, that's derivative of the top is 0, times the bottom, which I know this is just.
If we know it's 0, do we have to put that stuff?
No, I'm putting it there so you know that's derivative of the top times the bottom, minus the derivative of the bottom. Now, here's the goofy part. The derivative of the bottom is going to be this, and this is a part of the chain rule. The derivative of e to the 3x is e to the 3x, and then you have to take it times the derivative of 3x, which is 3. Okay, does that make sense?
Yes.
Plus,
So put that in little
plus,
parentheses.
yep, so plus, and now,
You have to put that in parentheses.
so,
Your e to the 3, that part. No, the whole.
The whole like e to 3x times 3.
Oh, it's order of operations.
The
You
more
don't have to.
parentheses,
You
the
multiply
better.
first anyway.
it's getting confusing, I don't even. Alright, okay, so now, the derivative of this, because again, these are just being added, so you just take the derivative of each one separately, that's
And
the
then,
sum
and
of difference
then
rule.
ln 7.
So yeah, so then it's ln of 7 times 7x.
I should write this.
This part, that's the derivative of 7 to the x. It's ln of whatever the base number is times 7x, 7 to the x, I should say.
And then the bottom.
Times the original.
And then over the bottom squared. E to the 3x plus 7 to the x. And this is all squared.
Awesome.
Oh.
If we do leave the 0,
That's fine.
that's fine.
I'm looking to see, like, really what I'm looking for in the major part, other than, getting the start down, is like this part. Do you know how to find the derivative of that? That would be like a major thing I'm looking for. Do you know how to find the derivative if it's like 7 to the x, because I didn't have any of those before this? Do you know that you need to square the bottom, that type of thing? Now, there is a different way to do this problem, which would be more chain rule than this thing. This
Do
is
not show us.
this is the other way.
No, don't show us.
Then just close your eyes, because I'm going to show you. So, because it is easier than what I just did. All right,
My notebook.
You gotta write that in the quote book.
No, I didn't.
all right.
Close your eyes, I'm gonna show you.
All right. So I would move the denominator up. Move. All right. Move the denominator up. And then we would take the derivative. Now, if I move the bottom up, that's what you get, and then you take times 1 is just itself. That's chain rule. That's this. What you're looking at here is that problem. It's just a different look to it.
That's the
So-
answer.
So no. This is just the original problem number 8 written differently. I moved the bottom up with a negative power, right? That the negative power moves it to the top, and I took it times 1, which is just this, because there was a 1 on the top. If there was like a 2 on the top, fine, I take it times 2. But there was a 1 on the top. Now this is the function for number 8.
Knowing you, you're gonna put like 8 out on.
It's fine, just put an 8 up front. But then all you do is the chain rule. The chain rule is you drop the power up front. You drop the power up front, you subtract 1 off the power, and then you take it times
The middle of
the
that.
derivative of the inside, which is e to the 3x
Times 3.
I feel like that was
3,
circumstantial.
plus natural log of 7 times 7 to the x.
What has to happen?
And that's the derivative of the inside. But that's what you're seeing there. That is the same problem I just did. It's just written differently. This thing would go to the bottom. This negative 1 would get multiplied over here because it would just slide over since this thing went to the bottom. It's that thing. It's the same problem I just did.
I know what you're doing.
It just looks different.
Ow.
All right. But again, if you want to do quotient rule, do quotient. If you want to do like a massive chain rule, it's probably a smart idea. I thought this was a lot easier than that one. It's the same problem. Okay, questions?
Nope.
Okay, all right. Now, if you were tuning out, you can do that.
Okay.
All right.
I
If
was
your eyes
tuning
were
in.
closed, man.
I really did tune out.
He's done, he's cool, he's saying, he's like a
Okay.
stick.
Let's go to 9, 10, let's go to those. Now we got the trig functions.
We should show them.
10.
Okay, 10.
Ryan, did you say that third answer?
I just have a headache.
What are you gonna write these on like the board, like what, the cosine of equals whatever? You know those big rocks?
Just those
Wait, can we review it? What do you do?
You can do it. We did this.
Is it sine equals a cosine?
The stars on the board.
I think this.
Cosine equals
Oh,
a
yeah.
sine.
Mr. Ward,
And then like,
you know who Stan Lee is?
Yeah, the creator.
He died literally.
He died.
Last night I was watching the movie.
When?
What movie was I watching?
Last
Today.
Today?
Last night. I don't know. Last night. Do you want to hear?
No, he's not. He
You
died.
know how
I'm
Mr.
getting
Ward?
so-
I mean, he's not us anymore because
Last
he's
night.
dead.
we
So.
like all
Sorry.
movies.
Last night I was watching.
Okay. All right. Hey, this is one you need to know.
We need to get out of school.
Hey, derivative of sine is cosine. Derivative of cosine.
Negative sign.
So, that one here. Yep. Shh. Derivative of cosine is negative sine. Okay, these are the two main ones you need to know, and tangent is the other one that I could potentially put here, because that was the other one we talked about. Tangent is, derivative of tangent of x
Can you not put that one on there?
is 1 over cosine squared.
Which is just
Cross
secant.
out.
I found out that's just secant.
It's just secant squared.
It's just secant.
Secant
Squared? Never mind.
Can we just write that?
Okay,
I have a question.
these three are ones you have to have
You can't
memorized.
write that on the board.
No, I will not put it on the
You won't write down, why not?
These are the only things you really have to have memorized.
That's a lot.
Yeah, but
Yeah,
we
but
don't
we don't have to have
Compared
anything
to,
memorized for
what
other ones.
geometry you had to have.
That's not memorized. That's on the board.
They can't
Yeah.
remember the area of a rectangle?
No, but they had to use
We've
it
been
in all
learning
the
that
other
since
parts.
third grade.
I could tell that one, that one, that one, that one.
Alright, hey, you want a number 10, correct?
Yeah.
Good choice.
Good
Alright.
Good choice.
Good choice.
I
Alright.
wouldn't get the cone, and I don't think it's.
Let me scroll, we can take a look at this one.
It
Alright,
might be a struggle, but I get the rest.
Nope.
Next.
Okay.
I would not get cylinder.
if I was doing number 9, I'd do it by chain rule.
Alright.
Cylinder is just circles
You
and
gotta- you
height.
gotta find- yeah.
Okay,
Well, here.
10. This is a product rule, but it also has a chain rule in it because of the way that they have the powers. Now, if you don't like the look of this problem, you can rewrite it like this. This is the way that, I believe when we were in class on Thursday, some people preferred that they write it like this.
Oh, that bothers me.
Some people preferred this because they could see the chain rule better than putting like the weird 3s on it, because it made more sense for what you have to do. I don't mind if you left it the original prompt where you leave it like this. They mean the same thing to me. It's whatever you need so that you make more sense of it. So, on the first part, we're doing product rules. Derivative of this first, well, that's chain rule. It's 5 sine to the 4x, right, because you're dropping 1 in power, times the derivative of the inside. Well, the derivative of the inside is sine. Well, the derivative of sine is cosine. And notice when you write that, you don't put a power on it. Okay? So this is the chain rule. Drop the 5, sine to the 4x, and then derivative of the inside. And then this is all times the back. The back, I didn't really touch this yet. Does that make sense? Like, that was the derivative of the first times the second. Plus, now we take the derivative of the second item. Well, the derivative of the second is you drop the 3 out front, so that's 3 cosine squared x. Derivative of the inside, well, which would be negative sine, so times negative sine of x. And then we have to take that all times the first, which is sine to the 5th x.
And that's all?
And that's what I'm looking for.
That is so good.
Okay. Now, if you want to rearrange, you want to like change the negative sign around. But again, it is a chain rule, right? Because the derivative of the second item is you drop the power down, so it's 2 with the cosine. And then the derivative of the inside is just negative sine. Notice there's no power on it, it's just negative sine. And then you take it times the front.
Hey, I have a quick question. Like, can you scroll up?
Okay, hold on. I'll let this in. We'll go back up here in a second.
How do you do that? That's my question.
Yeah, I think I know what your question is gonna be.
That's number 10.
It's with the
Yeah, does the X just go away?
What else?
Are you doing 4x times
You,
4?
it's a chain rule, so you do derivative sine 4x, whatever that's, cosine 4x, and then you
Do the derivative of 4x.
derivative 4x, which would be times 4.
So,
Did not mean
Oh,
We
that's
can
how you
look
got
at
that
the
before.
answer.
big red spot right there.
What?
Okay,
Big red spot.
questions at all about that one? Alright, now I did have a question, if you didn't hear, Nicole showing the question, the one above it.
End up on that.
Why
Where's
has
the
it on my
2x?
hands?
Oh, wait, oh.
Alright,
So.
So- okay, number 9 here, this is the secondary question. The question predicted was coming about, from this part.
you would take,
When you take the derivative of this, it's a chain
did
rule.
you see that?
Alright, when you take the derivative of this, it's chain rule. Drop 3 out front, subtracted, times the derivative of the inside, which the 2 would go away, trying to be 0. The derivative of this is cosine 4x times
The complicated part.
that, which is the derivative of that, which is 4.
What?
You just say the answer.
I basically did.
He basically
You
did.
did. Not
Drosky,
basically,
so how about
did.
you actually do?
Okay,
No.
alright, last one. Okay,
You take that
this
square
problem.
times-
I don't
This-
know that right now.
Okay, this problem requires that you draw the original function, a rough sketch, then you draw the first derivative sketch and the second derivative sketch. I can basically draw all the sketches off the first one, but if you're not that way, find the first derivative, do the sketch. This requires that the 7-step method where you look at where the tails go, y-intercepts, x-intercepts if you can find them.
Question.
If you can find it. It's meant to go down kind of easy. If you can't figure out x-intercepts, just draw a generic look at what that thing's supposed to do. Because some people can't factor it apart or can't do the rational roots.
That one's ugly,
So-
because there's no easy y-intercept.
Okay, we'll talk about it here in a second.
Zero.
All right.
Zero.
Oh, no, you're right.
Yeah.
Never mind.
Mr. Moore, I have a question.
What?
So, if we just look at the first graph and then do the slope thing and draw the
Yeah,
derivative graph.
you get
you
the
don't
other
need-
slope.
Yeah, I know, but you don't want it to be super exact, right? Like that.
No,
would-
it's just rough sketches. Yeah, so,
Right.
like if I was looking at this one, I could go a little bit more in depth, but you know, it's to the power of 4, so I know the tail's gonna go the same direction.
Both ends.
It's negative, they're both going down. Okay, so I get a sense for, ooh, that's back marker. There. So we're starting at 0. I know that's the y-intercept and x-intercept, but you know, it's doing something like this
This
where,
was on our homework.
yeah, where it's kind of going down. The reason why it's power 4, the tails have to go the same direction. It's negative, so it's going down. I know it has one x-intercept, the y-intercept, which is plugging all the zeros, so it'd be 0, 0. I don't know if there's any more. So if there's more x-intercepts, what you can do is you can divide out the 0, which is basically just factoring out
Can't
x.
divide by 0.
It's factoring out x. That's what you're doing. And when it's got an x, it's x cubed minus 4x squared minus 6. If at that point, I would probably try to do the rational root theorem, you know, to figure out, you know, possible roots. This would be 6 over 3. You break down all these. Like, you're going a little bit too in depth.
We don't
I just
have
want
that.
I just want just kind of a rough sketch.
So that guy right there is.
Yeah, like that to me, you're fine. You got a rough
All we need
idea
is
what
that
it looks
right there,
like.
what you
What if we don't have a proper?
We don't need the
pump?
x-intercepts?
What if we just
No,
have-
it's just you're
They
in
don't
the
matter.
You don't
ballpark.
have that.
You're in the ballpark. They're trying to ask about like how many like squiggles you need to do. Well, I know this
So
thing
what
should
you-
turn
what you
around
do is good
3
enough.
times. And it's just roughly gonna look like that. That's
That's
yeah,
what
that's
I'm
fine.
learning.
That's the
That's my
original
graph.
graph. What I would assume it looks like.
Where-
Now, this graph could just look like this. It could just do that, because maybe there's no like turning points. But I know it's still hitting 0, so I at least have the idea right. What?
Three
Yeah,
turning points.
in theory, yeah.
Yeah, you
I'll
made
turn
it
directions
like
like
so many, you made it
One,
5.
There's
One,
1, 2,
two,
3.
3. See, yeah, I do too many.
Five.
So I do too many.
I bet
So-
Are you gonna
Huh.
count us off
Check it
that?
out. I
Um,
thought you said that.
yeah, I
Can
probably, like in that case, I probably would count that one.
Oh, you
so,
would?
My graph, because I drew too many turning points.
Well, you said if you didn't
So-
have.
Or- so like this.
You have it straight down
So,
wrong?
yeah, like this would be fine, because that is a
Okay,
representation.
I would do that.
Maybe it looked like more like
That's
this.
exactly what I drew, so that's good right there.
You're good. Yeah, because the one thing I will check on is like how many turning points should you have? Like draw using counting. Like there should be 3 turning points because it's a power 4, so you go down by 1. That's something I would check. But I'm not gonna go super in depth like, oh my gosh, you missed like the one extra step because it would take you an hour to figure it out. Like I'm not gonna do that. I just want a rough sketch.
Thank you, Mr. Ward.
Okay.
What is the extra
All right.
Is it
Ward, could you tell us the
like
sense
this?
of new word?
It's gonna look like.
step? Maybe not a better way to do it.
Positive. It'd be positive to 0, so it'd be like more like positive
Down.
to negative. So yeah, it'd be like,
Yeah, that's what I did on my.
be like this, probably the next graph.
But it has to go below the negative. It has to get into negatives before it hits 0. Yeah. It goes negative for a little bit. So you gonna show us?
Yeah.
Yeah, so if you figure out the first derivative, negative 12x to the third minus
How do I know whether it's
12x
gonna go up or
squared
down?
minus 6.
Yeah.
It's a power of 3, so the tails are going up here.
But it's negative.
It's going to go through negative 6.
It's negative.
Yeah, that's I've already flipped it.
Oh.
Normal like cube graphs go like up to the right, down to the left. I already flipped it over.
He's one step ahead of you.
So negative 6.
I did it.
It's probably doing something like this, maybe.
That's what I did on my.
Something like that,
That's
probably.
exactly what I did.
What about,
I do that just
how do we
wrong.
know that it's not a U? Is
Oh,
it
it's not
like-
you. Because it's an odd power. So
So
the
the
tails have to
tails
go
have to
opposite
go
directions.
Oh, that is so awesome.
Now, if you want to try to factor that thing apart, which
Oh
it
my
doesn't,
god, what did I just do?
you can do the rational root theorem again to figure out like where x intercepts are. You know, I'm looking for a rough sketch. Like, do you even understand like what a cubic graph looks like? Do you understand what a
That
fourth
doesn't have
graph
enough
looks like?
turns.
But
Sure
it should have
does.
2 terms. So it turned once, twice.
Oh, that's very minimal turn.
Yeah, minimum.
Quick
I
question.
saw that
Now,
in one of
I'm-
these.
I'm gonna probably warn you of this.
Not
Like,
a turn.
the problem I'm gonna give you will be probably factorable. Just saying.
Oh.
So you should be able to
No,
factor
don't do that.
to figure out x intercepts.
This is way
No,
easier.
just do it like this.
This is so much easier. Like Dobbs, more easy.
I wish you would just.
Do this problem, please. Just put this one on the test.
Wait, do you think?
Can this just be our test?
Can I turn this in right now as a test?
Group test, says Mr. Ward.
Says Mr. Ward Group.
All right. Okay. Practice guides. They're due tomorrow. If you know you're not here, fine. You're gonna take it Wednesday when you're back. We're taking tests in class, so be ready to go.
Tomorrow?
Just make sure that you know. Hey, brother.
Yeah.
Hey, just make sure on the practice guide you're going as far as I need to see. Like you're displaying that you know product rule or quotient rule. Like you're showing me that you know the basics. You don't need to go
Can I
like
show you the-
crazy.
What if I
Like
don't have
further
the
just
Check it out.
I can tell things when those derivatives don't look right.
Okay.
So.
Let me check. I brought 3 down.
Yeah, but you said
See, you're
that one
doing
works
it.
too.
Awesome.
You said the
Wait,
show.
okay, so this one has you.
You know this is mine. This will work.
Okay, I'm sorry.
Yeah.
Yeah, that one works. And so does the-
Why are you sorry? You
You can tell it's mine by my lunchtime.
Oh, just
Not my day.
Hey, everybody make sure your lunch
I'm gonna
number
read
is
your
at the
homework
top.
recognized period Wednesday.
Oh, Reese, we definitely didn't do
You
that
want
right.
this now?
What?
Oh, no.
Mr. Ward.
Well, don't take it now.
I-
If you wanna, if you
Sure.
wanna study
Oh,
what
it's
I
close
do,
like
you don't
4x.
take.
Sure.
I'll take it.
I mean, like, more check.
Wait, is it? Mr. Ward, we have a question. Nelson, you may have done this wrong.
Wait, I told you that.
Ray says you did.
Hey, wait.
This would be.
Mr. Ward.
Cosine
I was gonna have you make my
of
econ stuff.
Oh, yeah, please.
Because you're at the derivative of sine.
I would volunteer to help, but that's not my.
Whoa,
I can turn it.
that you made. You said that initially that you made.
Are you gonna keep your papers?
Mr. Ward, did I do it
Are
right?
you kidding?
No, I don't know what we're asking you.
Can you hand my econ paper and
I
for
forgot.
me more?
Wait, what?
Yeah.
Nielsen, you did it, okay.
Is that a minus or a
No,
Mr. Ward,
a multiplication? What? Multiplication.
how am I gonna grab about my college championship?
Probably waste your day.
So we're going to turn it general.
Now the graph on the average of how much colleges cost, like state.
Justin, come with me.
Private schools and
Oh, that is so true.
community colleges.
That is so.
Oh, what are you
You
doing?
can pretty much just copy someone else's graph, but you just have to make your own.
It sounds a lot like plagiarism.
What was this one? What was this one?
Public speaking.
Oh, no, you can plagiarize